Now let us look to this question number 10. Determine whether following equations are identities. Meaning this is the equation. Equation means which will have equal to, right? So equation, this is the equation. Equation will have left hand side and right hand side, correct? So this is the equation because here we have left hand side and there we have right hand side. So is this the identity? The question is asking you this. Meaning is this true? So let's check. Left hand side equal to, we have cot square theta plus cos theta. This is the left hand side. So let's solve this left hand side. If finally we will be able to get right hand side, then this equation will be the identity, otherwise it is not the identity, correct? So in place of cot theta, what can I write? Cot theta, do you remember cot theta formula is cos theta upon sin theta. So cot square theta formula will be cos square theta upon sin square theta plus cos theta. So can I take cos theta common? Here we have cos theta, here we have cos theta, right? So let me take cos theta common. What will remain here? 1 cos theta will still be there. Cos theta upon sin square theta plus what is remaining from here? 1, correct? So this is not equal to what? Right hand side. What is the right hand side? This is not equal to right hand side, correct? In the right hand side we have what? Sin square theta. But are we getting sin square theta when we solve left hand side? No. You solve left hand side, and if you are able to get right hand side, solve this left hand side, and if you are able to get right hand side, then this equation will be the identity. Otherwise this equation is not the identity. Here we have solved left hand side and we are not able to get sin square theta, meaning right hand side. We are not able to get right hand side, so this equation is not the identity. Here we have Roman number 2. Let's go with the same way. Left hand side. What is the left hand side? Left hand side is tan theta plus sin theta divided by tan theta minus sin theta. We all know that in place of tan theta I can write sin theta upon cos theta, correct? Sin theta upon cos theta plus sin theta. In place of tan theta just write down sin theta upon cos theta minus sin theta. What common can I take from here? Sin theta can I take common? Take sin theta common. Sin theta can be taken common. If you take sin theta common, then what will remain here? 1 will remain, correct? So 1 upon cos theta plus what will remain from here? 1, correct? Therefore in the denominator also take sin theta common. Sin theta if you take common, what will remain here? 1. 1 upon cos theta. 1 upon cos theta minus sin theta already taken out, right? So here 1. Sin theta can I cancel? Do you remember that reciprocal relation? 1 upon cos theta, what is the formula? Sec theta, correct? Plus 1. 1 upon cos theta, sec theta, right? Please look at the video where I have uploaded a short formula, correct? So 1 upon cos theta sec theta minus 1. And is this the right hand side? Yes, this is equal to right hand side. That means when you solve left hand side and you are getting right hand side, means this equation is the identity. Roman number 3. Let's carry out in the same way. Left hand side. What is the left hand side? Tan square theta minus sin square theta. In place of tan square theta, what can I write? I can write sin square theta upon cos square theta, right? Tan theta formula is sin theta by cos theta. So tan square theta will be sin square theta by cos square theta minus sin square theta. Correct. What common can I take? Sin square theta can I take common? Yes, I can easily take sin square theta. I have taken common. What will remain here? 1 upon cos square theta, correct? And then minus what will remain from there? 1, correct? Then next will be what? Sin square theta 1 upon cos. Do you remember reciprocal relation? 1 upon cos theta is sec theta, right? So 1 upon cos square theta is sec square theta minus 1. Again, do you remember this formula? Sec square theta minus tan square theta equal to 1, correct? So from here sec square theta, this plus 1 bring this side, minus 1 equal to what? Tan square theta. Sec square theta minus 1 equal to what? Tan square theta. So in place of sec square theta minus 1, I can write tan square theta. And is this the right hand side? Yes, this is the right hand side. Tan square theta into sin square theta, right? Tan square theta into sin square theta. This is the right hand side. That means this equation is the identity. We have Roman number 4. Let's do this equation. Left hand side. What is the left hand side? Tan phi into cosec phi. So in place of tan phi, do you remember tan theta? Tan theta equal to sin theta by cos theta. So tan phi will be sin phi divided by cos phi, correct? And then we have cosec phi. Cosec what? Phi. That means sin phi upon cos phi into cosec phi can be written as 1 upon sin phi. You remember sin and cosec, they are reciprocal of each other, correct? So sin phi cancel. What will remain here? 1 upon cos phi, and 1 upon cos phi equal to sec phi. So that means this is the right hand side. Left hand side equal to right hand side, meaning this equation is the identity.